Okay, welcome everyone. We are working with slicing data frames using logical statements. And there is a link to this Colab notebook in the description of this video. And we're going to be working with a data frame that we load from an external CSV file. And if you've been running all of these code cells in the previous videos, then you're all caught up. If you're just opening this up and for the first time and you want to practice answering this question, you are going to need to load that data frame and clean it up before answering this question. And let me just show you where to load that data. You are going to want to come to the section of this notebook where you load CSV files. So you're going to want to run this code cell that has the run CSV command. So that's going to load this CSV file that we did earlier into a data frame called bike store. There are some issues with the data. You don't need to run this summary output. We needed to clean it up. So in order to clean up that data, you will need to run this code cell, which gets rid of the missing values, converts categorical data to factors, and then excludes some of the variables that we're not interested in and slices out just the columns that we're interested in. And if your summary data for bike clean after running this code cell looks like this, then you're ready to go and answer question 4. So then I'll scroll down to question 4. And now we're going to use that bike clean data frame to answer these questions. So this is asking us to use logicals and indexing to create data frames that satisfy certain conditions. So question 4a is saying, well, let's create this, and it's going to be useful for me to just get a glimpse of the first couple rows of this data frame in order to answer these questions. So this is going to help me just kind of see the ordering of the columns, for example. So I would like to keep just the product lines equal to road. So this means I want to keep only the rows. So this is a logical test. So for the rows, right, we're going to have a logical test, and that logical test is going to be contingent upon the product line. So we're only going to keep product line that is equal to the character string road. And that's only going to keep, so for example here, the first observation out of these that would be kept would be this one over here. All these other ones would not be kept. And next, that's going to tell us which rows of our data frame are we going to slice off. And next, I would want to indicate which columns do we want to keep. And this is saying we don't have anything as far as the columns go. So it says all observations. Okay, so we're not going to limit any of the columns. We're going to pull off all of the columns. You can see here, yeah, this kept row 6 because that had road as the product line, and it's only keeping, it seems to be working great. It's only keeping the rows that have product line equal to road. For B is now saying, let's keep all of the observations in bike clean that have a list price that is strictly less than the average list price. And we're going to assign that new data to a data frame name below average, which we have over here. And so one way to do this would be we need to know what the average price is. So this is going to calculate the average list price of all of the prices in our cleaned up bike data. And if I want to print that to the screen, that would only calculate it and store it to average price. If remember, one way to both calculate it, store it, and print it to the screen would be to place it inside of parentheses. And now I can see what the average price is. Okay. And so now I can do something similar as I did up here, except when I choose my, ooh, that's not what I want to do at all. Let me just start from scratch. When I choose my rows, it's now going to be, the condition is going to be on the list price. And I want to only keep the rows that have a list price, which is less than the average price. And now I can either, I can type in this number over here if I want to, or I could just say that number is calculated and stored in average price. So I could just type average price, and stored in average price is that $1,107.34 or whatever. And now I can print the first 6 rows of that data frame below average. And it looks like all of these list prices are indeed below that average. And if we look at the original data frame that we started with up here, this is indeed excluding this one. This was above average. This was above average. This was above, and above. But it did keep this one, which was below average. So that seems to be working just fine as well. Awesome. And we didn't subset or, select any subset of the columns here. We left the column index blank, so we kept all of the columns from the original data frame. And 4C is asking us to combine both of the conditions from 4A and 4B. So we want to keep all observations with a list price which is less than the average list price and has a product line which is equal to road. So that's an and logical statement that we're going to want. We're going to want to connect 2 logical statements with an and there. So the first logical statement is this one over here. And just to align my things, I'm going to just line it up over there. And then the other logical test was we wanted the product line to equal road. And then we want to keep all of our observations. So this would work. So this is saying we want to keep the observations that have list price less than the average price and the product line equal to road. And if it helps, sometimes it's nice to put these in quotes. So we can put these in quotes. Oops, want to not move that up. So over here, I've got kind of my first statement and then my second logical statement. And this is only going to keep observations that satisfy both of these conditions. So just going back to the kind of original one over here, it's going to say this one it's not going to keep because the product line is not road. So even though this is indeed less than the average price, this is not road. So both of them are not true. That's not going to be kept. So it's actually not going to keep any of the rows that I'm looking at here because none of these have product line equal to road. This does have product line equal to road, but this list price is bigger than average. So these first 6 rows would not be kept based on this subsetting. But here we can see all of the rows that are kept from this subsetting. So here we kept all of the product lines that are equal to road. We kept all of the observations in addition that have product line equal to road and have a list price which is less than the average list price. So that's how we can subset using logical statements, and we can combine multiple logical statements. In this case, we combine them with an and. We could have done that similarly with an or, and you can combine more than 2. We could have combined 3 statements with ands and ors, and you can make this as complex as needed based on the situation. And kind of one last thing I want to say about this example is when we created this subset with this average price example, I calculated this mean average price separately. I could have just done this all at once. So there's no reason why I had to calculate the average price outside and store it to average price. I could certainly have just calculated the mean average price inside of the logical statement, and this would have done exactly the same thing. This might be a little bit more complicated when you do everything combined in one command. Breaking it up into separate commands might help make it a little bit more readable, but that's your call. So feel free to do as you wish. Okay, thanks everybody.